Hello Math 2413 students. Let's begin Lesson 5, Differentiation 2. As the title suggests, this is a continuation from Lesson 4, Differentiation 1, which means it calls for a review. Let's begin with a review. Let's begin with a brief review on Lesson 3. In Lesson 3, we defined the derivative function like this using the Newton quotient. Yes, we could have used the average rate of change formula, and then we get an instantaneous rate of change function. We could have done that too. Either way, they're the same. And then we went through some differentiation rules. First, the constant rule, and then the addition rule, and then the coefficient rule. Now for each individual term, we'll have to use some differentiation rules for power function. Yeah, this is the most important. Or the derivative rule for the natural exponential function. Or the derivative rule for the natural logarithmic function. 1 over x or x to the negative first power, they're the same. And then we went through a bunch of exercise problems. Remember? Basically, that's what we did in Lesson 3. Now, in Lesson 4, we went through the product and quotient rules. Here's the product rule. And then here's the quotient rule. See the similarity? Let me expand the font a little bit. Look at the denominator. We have v squared. That's so conspicuous that people don't usually miss it. The numerator is the problem. Look at the numerator, u prime v minus uv prime, and then cross-balance with the product rule, u prime v plus uv prime. Aren't they similar? Yeah, they're similar, and that's how you can associate these two. And of course, they're not coincidence, as a matter of fact. When you actually go down to the proof, you'll see they're connected. But that's a bit too much for most people. So let's try to memorize like this. We have a product, so that's multiplication. And here we have a quotient, that's the division. Multiplication goes with the addition. Then we take the inverse. The division will go with subtraction. You see? Addition versus subtraction, multiplication versus division. They're inverse of each other. I hope that's a good way to remember this. If you choose another method to memorize all those, fine, go ahead. In any case, I demand precise application of the product rule and the quotient rule, especially the quotient rule. I see more errors from here. And then please remember some generalized product rules too, for 3 factors, 4 factors, 5 factors in general. Okay, that was a brief review on product and quotient rules. And then please recall trigonometric functions. We went through trigonometric functions in Lesson 4, and here are the trigonometric limits. The first one here is extremely important. Second one is important too, but the first one is far more useful in a lot of regards. And then we went through a lot of exercises utilizing this one. And then we have some derivative formulas for sine and cosine like this, and then those for other trig functions. Tangent and secant versus cotangent and cosecant. They're similar, but co-trig functions have negative signs here. And that applies to cosine as well. So co-trig functions, cosine, cotangent, cosecant, they all have negatives flying around. Okay, so much for the review, and finally let's go over to the new topic, the chain rule. Ready? Okay, here we go, and here is the chain rule. It's a derivative rule for a composite function. The derivative of f of g of x is f prime of g of x times g prime of x. And a practical way to do this is to follow this 3-step process. As I color-coded, outside first. and then we go in. And then inside, stay the same. No change there. And then step 3, multiply the derivative of the inside, g prime, not back in because inside stay the same, but like a dangling chain. Dangling chain like this. And if you repeat it, you really get a chain. Well, we have a proof here, but I don't think many people are interested. So without those, let's just go ahead with some exercise problems here. Let's begin with some simple problems first. And then we're going to go to a little bit more complicated examples that we have to use chain rule multiple times so that we get, indeed, dangling chains after chains after chains coming. Okay, let's begin with the first problem. So we have x squared plus 1 to the 1/2 power. Remember, we have square root here. This radical can be changed into power form, and that usually is the starting point of a lot of calculus problems. Not a lot of calculus problems, nearly all calculus problems, whenever you have some radicals flying around. Okay, the preparation is done, and let's apply the chain rule. And what does it say? Step 1, outside first. What's the outside function here? It's 1/2 power function. So let's apply the power rule. Power comes out, and then subtract 1 from the power. That's step 1. Let me highlight it in blue. So 1/2 power, that comes out as coefficient, and then subtract 1 from the power. Now let's go to step 2. Inside stay the same. So let's just copy and paste this thing inside. And that's step 2. That was easy. And then let's go to step 3. We have to multiply the derivative of the inside. What's the derivative of the inside here in this case? 2x. And let's highlight that in green. That completes the problem. What do you think? Simple enough? Step 1, outside. Step 2, nothing changes inside. And then step 3, the chain. Now step 2 is so simple that later on, I'll just combine that as step 1, and then just copy and paste, and then go ahead to step 3 directly. So instead of going this in 3-step process, I'll consolidate 1 and 2 into a single process, and then go with 2-step process. But for now, let's stick to 3-step process, because I saw so many students making mistakes here inside. Take the derivative and putting it inside. Such a common mistake. I really want to avoid that, especially early on. And that's why I singled out number 2. Even though we are not really doing anything, just copying and pasting, still I singled it out as a special, separate process. Okay, all right. How about the next problem? You can stop the playback and do it on your own, and then you can check later. So what do you have here? First, the preparation. G of x is 3 times 3x squared minus 2x plus 5 to what power? Negative 1/2 power. Is that clear to everybody? Why 1/2? Because we have square root. If this had been if this had been cubic root, then we'll have 1/3 power. 4th root, then 1/4 power. Now, why negative? Because this entire thing came from the denominator. So, denominator gives me negative sign, and then 1/2 power comes from square root. Alright, the preparation is complete. Let's calculate the derivative. The chain rule says outside first. Apply the chain rule, apply the power rule to the outside. Multiply the power -1/2 times 3, so you're going to get -3/2. And then subtract 1 from the power. What is it? -3/2 power. Let's highlight it in blue. And we have this -3/2 and another -3/2, but that's just a coincidence. What really happened is just multiplication here that gave me -3/2 and subtracting 1 further. That's how we get -3/2 there. They're not directly related. Now, step 2, inside stays the same. No change there, just copy and pasting. I've seen so many mistakes here doing something inside. Don't do anything, just copy and paste. Nothing changes inside. What changed then? We multiply the derivative of the inside. Right here, like a dangling chain. So what's that derivative? What do you get? You get 6x minus 2. Did I do this right? There you go. That's a derivative computation. Step 1, step 2, step 3. Okay, we have another. Stop the playback and try on your own. Exponential of 3x squared plus 2x. Okay, alright, that's what we have here, but it's hard to read, so let's expand the font. And let's calculate the derivative. Alright, go ahead, what do you get? Derivative of the outer function. It's a natural exponential function, but that stays the same. And then how about the inside? Inside also stays the same. Doubly, they stay the same. And then by chain rule, you have to multiply the derivative of the inside. So what is it? Derivative of the inside, we have 6x plus 2. Is that right? Well, that completes the computation. There and there. And we have all these problems in the same viewing window. Just one use of chain rule for each. Blue, outer function, red, inside stay the same, and green, chain. Step 1, outer function. Step 2, no change. Step 3, chain. Now in this case, step 1 and step 2 takes place together at the same time because it's an exponential function, so no change. Inside, again, no change, just copying and pasting. And then the chain part, the derivative of the inside. Okay, so much for elementary chain rule problems. We'll have more complicated problems in separate videos.